Hello, everyone. Welcome to reInvent. My name is Shandor Maurice. I'm a Senior Engineering Manager with AWS. Joining me in this presentation is Josh Eichhorn. He is the CTO of Pagely. So we are here today to talk about Aurora Serverless. Thank you for joining me. So before we get into Aurora Serverless, I wanted to call your attention to a few related breakout sessions that you may want to attend if you want to look at Aurora more broadly outside of the scope of serverless. So on Tuesday, tomorrow, we have What's New in Amazon Aurora, 1 p.m. here in the Venetian. We also have at 6:15 p.m. Deep dive on Amazon Aurora with MySQL compatibility. You may want to check that one out as well. And then on Thursday, we have Amazon Aurora Storage Demystified, also here in the Venetian. So please check these out if you're available. I think you'll find them very interesting. Now let's start by taking a look at what we're going to be covering today in this presentation about Amazon Aurora Serverless. We're going to start briefly by catching everybody up on RDS and Aurora fundamentals. Then we're going to talk about Aurora Serverless. What is it? How does it work? We're going to get closer to the end talking about what's new in Amazon Aurora Serverless. I'm going to be talking about some features that we've just recently launched that I think you're going to find really useful. And then I'm going to hand it over to Josh, who's going to talk about the way that they use Aurora Serverless at Pagely. So with that, let's take a quick look at what is RDS. So RDS stands for Relational Database Services. We offer a platform that provides management around a whole variety of relational database engines, including Amazon Aurora, which is our homegrown cloud-native relational database engine. But we also do, of course, support MySQL, MariaDB, and Postgres, the open source engines. And we do, of course, support SQL Server and Oracle, the commercial database engines. Now, as part of RDS, you get all of these capabilities out of the box without having to do any extra work for them. So let's jump to, well, what is Amazon Aurora before we get to talking about Aurora Serverless. So like I mentioned, Amazon Aurora is our homegrown cloud-native relational database engine. We made it generally available back in 2015, and we've been really excited by the adoption for it. Now, Amazon Aurora gives you the speed and the availability of high-end commercial database engines. Many of you have tried to use it, and you found that with traditional databases, you don't get the kind of availability and performance that you might want. Aurora does give you that capability the same way a commercial database engine might give you, but it gives you that with the simplicity and cost-effectiveness of an open source database engine. It is fully drop-in compatible with MySQL and Postgres, so you can migrate in and out without having to change your application. And it's simple pay-as-you-go pricing, so there's no vendor lock-in, there's no licensing involved. We earn your business every hour of every day. This is delivered as part of RDS as a fully managed service. Now let's take a quick look at what is the architecture of Amazon Aurora. So the key innovation to Amazon Aurora is our purpose-built log-structured distributed storage layer, where what we've done is we've taken the whole storage layer of a relational database and pulled it out into a multi-tenant process, giving you a highly elastic data volume. What we do behind the scenes is we break down your data into 10 gigabyte chunks, and we store 6 copies of it, 2 per availability zone. What that gives you is the ability to survive an entire AZ outage without any service disruption, without any performance degradation, and without any data loss. Now, the nice thing you can do about this is you can create your master database, and you can also create up to 15 replicas that are both useful in terms of serving your read traffic, but they can also act as failover targets because they're attached to the same storage volume, so you can failover without any data loss. But now let's get to talking about what do we need serverless for in the context of Aurora. Well, one restriction you still have with Aurora provisioned is that you need to provision your database server. You need to decide on what size server do you want to operate on up front. Now, the industry standard thing to do is to peek for your provisioned workload. A lot of the time this works. Sometimes it doesn't work so well from a cost efficiency standpoint. So one thing we find our customers often doing is they'll continuously monitor and manually scale up and down their database server as their workload fluctuates. So this is where we get to Aurora Serverless. So in order to solve this problem, we started by looking at offering a solution where you don't have to monitor your database server anymore. You can simply run your workload, and it will automatically adapt to your workload as things change. So Aurora Serverless will automatically scale up and down based on the capacity that your workload consumes, and you don't have to think about it. When your database becomes idle, we'll automatically shut down your database server. When your workload resumes, we'll automatically spin it back up. So this is the core to what we're going to be talking about today. Now, Aurora Serverless, we announced it last year at reInvent, and we made it generally available this past August, 3 months ago. So to really make the case a little stronger here, we took a bunch of workloads from our production fleet. Here's one example where we saw this dev test workload. Now, we're looking at volume write IOPS. There's a lot of other metrics you could look at. But what was immediately obvious to us is if you were to draw this fake line across this graph and say, well, this is what you're provisioned for, what you would quickly notice is that for the vast majority of the time, you have resources provisioned that you're never actually using. So this is where we started in terms of inspiring us to go build Aurora Serverless. Now let's look at a couple of other sample workloads before we move on. This is an even more typical dev test. We see a lot of these in our production fleet today, where our customers provision for their peak workload, even for dev test instances, but they never actually use it. So this creates a huge opportunity for cost savings. Now let's look at some production workloads that we see. This is a sample spiky gaming workload where you have your daily peak coming and going. And even in this production workload, if we were to draw a line in terms of what you would provision for, you would quickly find that you're paying for a lot more than you're actually using for the majority of the time. And here's zoomed in an e-commerce production workload. I promise this is the last one, but it's really the same story. So in terms of provisioning your database cluster, you have a few choices to make. You can provision for peak, and this is sort of the industry standard. This is what you typically do for any production workload that you actually care about. Or you can under-provision. Now, this is probably not what you do for a mission-critical workload because you're going to have end-user customer impact if your database server isn't large enough to handle your workload. Or, like I said earlier, you can continuously monitor and scale up and down, but this creates risk to your business because every time you do scale up and down, there's the potential for downtime, there's a lot of expertise involved, there's the risk of data loss, and I'm going to be getting into the details of what that looks like and then talking about how Amazon Aurora Serverless solves that. So in terms of database management, let's pretend you're going to go and manually monitor your database fleet and continuously scale it up and down. You might have an architecture that looks a little bit like this. You're probably going to have more than one application server, but we'll just have one for the sake of simplicity. So a typical scaling operation is going to look like going ahead and provisioning a larger replication. We'll call it a scale target. Now, this is easy with Amazon Aurora because you don't need to worry about replication. That's all done for you down at the storage layer. But for a traditional database, you actually would have to do that yourself. Now, you're going to go ahead and cut over. OK, now you've failed over to the new master. Now you're running on a larger box. But the problem you're going to run into is that cutting over from your smaller database server to your larger one can often involve downtime. And even after you've done the cutover operation, your performance is going to be compromised for some period of time because now you need to warm up your buffer pool, load up your caches, and do a lot of things to get back to the same performance level you were at before. Now, what we see a lot of customers doing to reduce this problem is they'll add a proxy layer in the middle that basically makes the workload cutover a lot more seamless so that application servers don't have to worry about rerouting their traffic. So a cutover will look a little bit something like this. And as you notice, the application server has not had to redirect anything. But there's a couple problems you're still left with having to solve. One of them is now you've introduced a new single point of failure to your service. So yes, you can have multiple proxy servers. There's a lot of things you can do, but it really adds to the complexity of your operation. The proxy solution also doesn't solve for you this problem that after cutover, there's some period of time when your performance is compromised because you are starting from a cold buffer pool. So let's talk about Aurora Serverless and how it solves some of these problems. As I mentioned earlier, Aurora Serverless was designed to automatically respond to your application workload. It will scale you up and down without any downtime. What we have is a multi-tenant proxy layer that we've added to make sure that there's no single point of failure introduced. You don't have to manage it. This is all done for you. And finally, the scale target has a warm buffer pool, which means your performance does not degrade after cutting over. You continue running at least as fast, but probably faster because you're now running on a larger box immediately after cutover. And finally, when Aurora Serverless is not in use, the database will just go to sleep. So this is really ideal for dev test workloads. You can also use it for your heavier workloads where your traffic is highly variable. Now, when we announced Aurora Serverless last year, we got a very strong positive reaction from our customers. This is one that I'm really happy to share. Our friends over at Netflix to use a reference to one of my favorite shows, Stranger Things. Check it out if you haven't already. So we got a very positive response when we announced Aurora Serverless. A lot of customers like you were really excited about it. Now, what I want to get into next is how does it actually work behind the scenes? How does it solve these problems that I've described? So what we start out with is something that looks a little bit similar to what I showed before. You've got your application server fleet, you've got your database, but the first thing we did was we added this multi-tenant proxy layer where we have thousands of proxy servers that load balance horizontally without introducing any single point of failure. The next thing we did was we added a warm pool of database servers so that when we decide to make a scaling operation, we can swap hosts in and out very, very quickly. We also added a monitoring service that is going and checking the entire fleet, looking at how are the different database servers performing? Is anybody starting to exhaust their capacity? Might we need to start thinking about scaling them up or down? And so when you connect to your Aurora Serverless database, you're connecting through a proxy layer. Now, I did mention earlier that you can connect to any one of the multi-tenant proxies, and this is not something that you need to worry about because this is handled by a network layer load balancer. That you don't even need to think about. You connect to it as though you would any other database. Now, you can distribute your workload across multiple proxy servers, and you don't need to think about it, like I mentioned. So we have not introduced any single point of failure. Now, what we look for in terms of making scaling decisions is the monitoring service is sitting there looking out for any database server that has more than 70% of its CPU capacity utilized, or more than 90% of its maximum connections have been consumed. And if it finds a database server living in this state for more than 5 minutes, it'll go ahead and decide to scale up or down. Now, what you get with this is you grab a fresh database server out of the warm pool, so scaling operations can be executed very, very quickly without having to wait to provision a new server. We're able to transfer the buffer pool to the new cutover target, so you don't have to worry about that, and you get fast performance immediately after cutover. And finally, we look for what we call a safe scale point, which basically means we look for a point where your production workload is up and running, but there's no single long mutating transaction that we can't easily transfer over to the new box. So you don't have to disrupt any of your in-flight transactions when you do the cutover. We find the safest point for you to scale so that your application doesn't feel any downtime. Now, when we do one of these cutover operations, what we're going to do is momentarily freeze your application workload. Now, this doesn't drop connections. It just basically parks all the transactions at the proxy layer. And during that brief period, we're going to take all of the transactions that are in flight, we're going to take all of the sessions, and we're going to move them over to the new scale-up target. What this means is that when we resume your workload, it looks as though nothing happened. All your application experienced was a very brief spike in latency. And because we have the warm buffer pool, as I mentioned before, you're not going to see any performance degradation following this cutover. Now, when the workload becomes idle, when your application stops sending traffic to your database server, we're going to go ahead and shut down the database and save you a little bit of money. When your workload comes back, we're going to spin up the database. We're going to take a server out of the warm pool and keep running as if nothing happened. Now, as I mentioned earlier, the proxy layer is designed in such a way that we have not introduced any single point of failure. We can horizontally distribute your connections across the proxy fleet, and you don't need to worry about introducing anything that's going to take your workload offline should a single server fail. Now, let's take a look at what this actually looks like in practice. Having gone through all this, it sounds great, doesn't it? I want to take a look at some graphs. This is an actual workload that we created. We ran it against a serverless database. What we're seeing here is transactions per second over time. So we're basically going for throughput. Now, this is looking down at the 1 second granularity, so you can really get a feel for what this actually looks like as an application server. So we go ahead and start running our synthetic workload, and we basically push the box to its maximum capacity. And what we see over time is these drops in transactions per second when we're performing the scale operation. And then when it comes back, it's up and running at the next level. Now, let's see if our nifty animation, okay, it's thinking about it. There we go. What we have here is overlaid our transactions per second with the actual capacity that's been provisioned behind the scenes. So you can see how the Aurora Serverless database is reacting to the synthetic workload that we've created. You can really see the capacity that's being added, and each time the scale operation happens, you see this momentary drop in throughput, but there are no connections dropped. And so from your application standpoint, there's a very brief slowdown, but things get right back up and running in a small number of seconds. Now, midway through this, we go ahead and slow down the synthetic workload, and we can see Aurora Serverless gradually scaling its capacity back down. Then finally, at the end, we go ahead and shut the workload down, and we can see the Aurora Serverless database going to sleep. Now, here's a similar overlay where I'm tracking latency instead of transactions per second. So we can see that each time a scale operation happens, there is this very brief jump in latency corresponding to the increase or decrease in serverless database capacity. But it's really not very noticeable to your application because it lasts a very small number of seconds, and as I keep mentioning, there are no connection drops. And finally, just to round out the picture here, what I'm showing you is throughput mapped against latency. So we've got transactions per second. We've also got latency in terms of milliseconds, and you can see how they correspond. Now, we built all this. We made it generally available in August, and we've been really excited by the response so far. But one thing that our customers have said to us is that Aurora Serverless is really just auto-scaling for databases. And that is actually true. A lot of what we initially offered, it certainly does give you automatic scaling capabilities, and it does this in a very seamless way. One thing we had not necessarily done was make this really, really simple and easy to integrate with other AWS serverless technologies. So that brings us to the what's new of this presentation. The first thing that I'm really happy to share with all of you is what we call the Rds Data Api. So what the Rds Data API is going to allow you to do is connect to your database without any dedicated JDBC or ODBC connection, without any custom configured driver. You can actually send both queries and mutating operations to your database through a simple web service API protocol. Now, these are actually packaged as HTTP requests. You don't need to worry about connection pooling anymore, and you can really access your database from anywhere now. Now, we've made it really, really easy to access your database from AWS Lambda and AWS AppSync, and I'm going to describe how that was made possible in just a moment. You can also access your database from the AWS Software Development Kit or the command line interface. So that's the Rds Data API. The next thing I'm really thrilled to share with you is the Rds Console query editor. So many of you have probably used the Rds Console before. You're quite familiar with it. Well, now you can actually run queries right in the console itself. You don't have to go and spin up a dedicated database client. You don't have to create an EC2 server to connect to your database anymore. You can run your queries right from within the AWS console. I'm also really happy to share with you that we have, as of last week, opened up a preview to support all of the capabilities that I've described, not only with MySQL compatibility, but also with Postgres compatibility. So I hope you'll go ahead and sign up for the Aurora Serverless Postgres preview. It's available today. Sorry for the long URL. You can also web search it, and you'll find the same page. We've recently added Aurora Serverless support in many, many more regions. I'm not going to read off the full list, but we want to make this a truly globally available service. As of 2 weeks ago, we made this all available. And now what I want to do to tie a lot of these pieces together is to run a little bit of a live demo for you. And before I do that, I'm going to describe what's going to happen here. So this is going to require some audience participation. I'm going to take an audience poll and see where is everybody from, and then I'm going to show for you the results in the Rds Console query editor. Okay? So the way this works is you're all going to take your phone out and send a text message. Now, I'll share with you the phone number in just a moment, but you're going to send a text message, and in the body of the text message, all you need to do is specify the city that you're from. Don't worry about country or anything like that. Now, what's going to happen is we have a Lambda service that's going to pick up those text messages, and it's going to send them down into an Aurora Serverless database, and then I'm going to go ahead and load that database up and show you the results right in front of your eyes. So when you're ready, go ahead and send the city that you're from to this number. Now, I'll just give it a moment while everybody sends their text message in. Okay, I hope you all got that. Now, what I have here in front of you is the Rds Console. Oh, I got some requests to switch back to the number. Happy to give it more time. There's no rush. Okay, I hope that was enough time for everyone. So I'm going to go ahead and switch over. This is the Rds Console that many of you are probably familiar with. One of the things we've added is the query editor that I'm going to show you right now. So we could go to this query editor. It's going to have us choose the database that we want to query against. Pardon me, folks. There we go. Got to choose the cluster. There. All right. Now, this is the table. We're now logged into the database that is storing the results from the text messages that you just sent. Let's go ahead and show tables, see what we get. Sure enough, there's a table called cities. So I'm going to go and look what is in this table. Now, contained in the table is basically the aggregated results of what you all just sent me. And by the way, I'm going to share all of this code with all of you after the demo. Let's go ahead and select city. And count from cities. Let me just fix this as count group by. It's hard to type when you've got a big audience. Okay, let's see if I typed it correctly. There we go. So we have a lot of people from Seattle with us here today. A pretty good group of us from Boston, San Francisco, Dallas, Los Angeles, Denver. Now, what I'm trying to showcase here is the fact that it's now really, really simple to build these dynamic, scalable applications and then to access your database using Aurora Serverless. Now, just to give you a quick sample of what this code looks like, this is the kind of code that you would write to access your Aurora Serverless database from your Lambda application. We have shared the complete code for this demo right here on this GitHub link. You're welcome to go and download it, make it your own, do anything with it that you would like to do. At this point in the presentation, I'd like to go ahead and hand it over to Josh. He's going to be talking about how they're able to leverage Aurora Serverless in Pagely. Thank you.
Thank you. So I'm Josh Eichhorn. I'm CTO at Pagely, and we're a managed WordPress hosting company. Hopefully you've all heard of WordPress. Last time I looked, it powers 32% of the web. And most of that you might think of as it's just used as CMS or a blogging platform, but a huge number of those sites are also e-commerce sites and fully custom applications. So what Pagely brings to the picture is everything you would need to run WordPress on Amazon at scale without worrying about any of it. And not only does that mean we're setting up the platform for you, but we're the DevOps engineers who get paged when something inevitably goes wrong. So think of us as bringing the peace of mind to running WordPress at scale. So we've been in the WordPress market for about a decade now, and we've seen it change and grow. And where we're focused right now is really on the larger scale of the market, enterprise customers, people who are doing really interesting things with WordPress. But as we talk to our customers, we find that our current offerings doesn't always meet their needs because it's really focused around that high-touch, white-glove service. We take care of everything. And sometimes a customer just wants a platform to run things on. And so that's why we've been building a new product called NorthStack. And so that just takes the same serverless application concepts that you might get from Lambda, but instead of putting them at that infrastructure level, being able to run a full-blown application like WordPress on that platform. So you don't have to worry about any of the servers. You get an auto-scaling platform that is built in a metered way, just like any other Amazon product. But you don't have to do all of the work to shoehorn an application that was written almost 20 years ago onto the platform. Now, besides just that platform, we do have to change a little bit how you work to make that work. And so NorthStack also introduces the workflow that's needed. So it gives you a concept of doing releases. Since the only way to make those legacy applications work in a fully serverless way is to give up a little bit in how you work. You give it some flexibility, and you gain the platform. So this is the high-level architecture of NorthStack. So it's built on a bunch of Amazon services. The biggest ones are ECS and Aurora Serverless. But we also use EFS for places where we need to have shared storage among a bunch of different containers. And we use S3 for all of the bulk storage. So an interesting thing is that we have a bunch of different sorts of applications they might run on WordPress. And one class of them is that standard CMS use case. And the goal there is that you only want to use a very small part of the platform the majority of the time. So the very first, the application gateway ECS containers there are running our Nginx custom caching layer. And your goal in the CMS applications is to serve the vast majority of your traffic there because that allows you to do it the cheapest way. And only need to use the PHP layer that's running on ECS and the database when it's needed. So you want those pieces to be able to stop, which is really easy with Docker. You can just manage the lifecycle, stop the service when it's not used, and have something to start it back up. But it's much harder in the standard database world to do that. So the way we work it is each production application gets its own Aurora Serverless instance. And then the non-production applications are in a multi-tenant setup. So last year when we heard the announcement for Aurora Serverless, we were very excited because we were mulling how to solve this problem. So having a database that easily scales, that can stop, is really a hard problem. Kind of the classical approach to this might be you have a master, and then you scale out read slaves using autoscaling. But WordPress makes this really hard. So the standard pattern in WordPress is you do a database write, and then you immediately do a read to fetch the data, any fields that you might be missing around your write. And so that makes it very hard to get more than 20 or 30% of your traffic to go to a read slave, which means that doesn't really help your scaling problems. So you need to look at what the options are for scaling masters. So, and we do both these options right now, have lots of experience doing it. So there's the single tenant option. Say you're running on a provisioned Aurora. You have a read slave, you resize that, and then you do failover to do that. It has its problems, and you generally have around 30 seconds of outage around each scaling operation that's hard to get away from. And it ends up being a very high operational overhead. So the other option that we do, and it's more common for us, is we do multi-tenant. So if you use very, very large instances and have different customers share them, then you have a bunch of spare capacity. And everybody's sharing that spare capacity, so it makes it less expensive on the over-provisioning. The downside there is that you have to be very careful to know who those noisy neighbors are. Because once somebody uses all that spare capacity, it's not available for anybody else. So if you find somebody who's bursting all the time, then they have to be moved off that multi-tenant solution to a single-tenant solution. So again, very high operational costs. So as I mentioned earlier, we were really excited when we heard about Aurora Serverless because it's the perfect fit for us, right? It scales the master. We don't have to deal with downtime. We don't have all that operational overhead. And it has an answer to pausing. So if you're in that standard CMS use case and the database isn't needed unless you're adding new content, the solution's built right in. So over the last year, we've been building out North Stack, and we're in our early testing phases right now with real customers. And we've had a lot of great success, but we've also found some things that you need to watch out for when you're using Aurora Serverless. So I'll go into those from details. So the first one is that if you're using pause, and that's really the best way to see real money savings in a lot of our use cases, that resume time is inconsistent, so you need to plan around that. And as mentioned earlier, Aurora has to pick that safe place to scale. But sometimes it's your slow queries that are causing the load and preventing a safe place to scale. So you have to have an answer to that. And we noticed that, at least in the PHP case, we noticed more MySQL has gone away errors. And so you need to take some steps to manage those. So in our architecture, the goal is to stop the whole second half of the design when it's not needed. And so that means when a new request comes in, first we're going to wake up a PHP worker. It's going to then connect to Aurora. And then Aurora is going to on pause. And then it's going to be able to run the queries. And so starting a new task on ECS might take 10, 20 seconds. And then starting that Aurora, on pausing that Aurora instance might take, well, sometimes it's really quick, but oftentimes we'll see 30 or 40 seconds. And so when you do those two things back to back, you might be looking at 40 seconds or a minute, and that starts to get to the point where it's unacceptable. And so we had to look at, well, what are some ways we can reduce that time? So obviously we talked to the Aurora team, and hopefully in the future they'll be able to improve that time. But we can also improve it in our design. So, and this is the case of many things. Like, you might not be connected to the database until you need it, but if that database is paused immediately, as high up in the process as possible, and you want to connect to it and start it waking up. And so in our case, we have a dedicated service that's running, and its only job is when the connection is being sent from our load balancing layer to our PHP layer, it sends a connection request to the database so that it'll on pause. All right, so second case, the thing you really need to worry about is you got to give it a time. You got to give Aurora Serverless a place to scale. So let me tell you a little story about WordPress. So as I mentioned, it's a relatively old application, and it was designed not necessarily with everything was used today in mind. But it did have a lot of flexibility in its design. And the biggest part of that flexibility is this table called post meta. So a post can be many types, but it only has in that table 5 or 6 default fields. And anytime you want to add optional data, maybe that describes an order, if you're using WordPress for e-commerce site, or maybe it just describes different sorts of custom content that are being used to show the page. They all get stored in this post meta table. And if you look at the design of the schema, you can say, oh, well, as long as I only access things by post ID or meta ID, I should be in pretty good shape. And the most common access pattern is post ID. But you'll often get cases where the data that's in there is being used for filtering. And so instead of querying against those keys, you end up querying against either that large varchar or, even more painfully, that meta value. And because of the way that MySQL handles blobs in the tables, any query against this table is going to end up using a temporary table. So it's really easy to run on a small instance, and everything's fine until you do that one query that scans this table looking for a specific meta value. And then that query might take, if you're on a 2, the smallest Aurora Serverless size, that query might take 10 minutes to complete. And because it's using that temp table, there's no scaling point until it's complete or it's canceled. So for 10 minutes, your database is maxed out, but it can't scale. But if you would have been at 8 ACUs during that time, that query would have completed in under 2 seconds. So what you need to do is figure out how you're going to manage those runaway cases. Like Aurora Serverless will give you great results if you're doing lots of small, fast queries, and your load is coming by increasing the number of queries. But you have to have an answer if part of your workload could be these queries that take a long time. And so, I mean, the obvious easy answer is you want to start setting some timeouts. And as I was researching options for this, I was really excited because you look in the documentation and MySQL has support for max execution time. Unfortunately, that's in MySQL 5.7, and Aurora Serverless doesn't support that yet, though hopefully it'll be soon. So the long term, there's a really nice answer built right into MySQL. On a per session basis or globally, you can set the timeout. But until then, you need to set that timeout at your application layer. So if you have an application where you can't change anything in it, there is a nice option. There's a product, open source product called Proxy Sequel, and it allows you to set a query timeout, and then it manages killing the query when it goes past that timeout and returning an error to the client. And if you don't want to deal with all the problems that adding a proxy is, single points of failures, managing that, most clients have some sort of socket timeout, network traffic timeout that you can use as your timeout mechanism. So in PHP, that's the option you set. So in our case, most of the time, we're setting a 30-second timeout for our workloads with the ability for specific customers to be able to override that for specific sites. But it's also very important when you're thinking about those timeouts is you often have a reporting query, a database import, where it might need a much higher timeout than normal. It's just a query that you don't run very often, but is going to take a long time. And so you have to have some application-specific awareness about how you apply those timeouts. There's no just global solution. 20 seconds will always work. So then the final issue we ran into is that we'll get an increased number of MySQL has gone away errors. Now, it's not entirely clear to me why we see this. One theory is that it's just you're connecting against the proxy layer, and you have shorter inactivity timeouts than you do when you're connecting to your own RDS, and that the MySQL client doesn't manage that well on its own. But I think if you're using any language that's using or following the same patterns as the MySQL C library, you're going to run into the same increased number of servers gone away errors due to how it's managing timeouts on sockets. The nice thing is you can just catch the error and reconnect and everything's fine. But it is something that you want to test around and be aware of. All right, that's everything. Thank you. And
Thank you, Josh. Appreciate you coming on stage and sharing with us your experience of using Aurora Serverless. We did want to open up the floor to some question and answers. We do have microphones set up in each of the aisles, so if you want to go ahead and step up and ask any question you'd like, I'm happy to try to answer that for you, or any question for Josh for that matter as well. So does anyone have any questions they'd like to ask? And just as a reminder before we get to questions, please make sure to fill out the survey in your mobile application. Thank you. It looks like we have a question right over here. Yes, sir.
Yes, so question is when we have a downscale the instance, what happens to buffer pool? What is the strategy of downscaling of the buffer pool?
So it's the same strategy in that we do pre-warm the buffer pool even when scaling down. However, we are scaling down to a smaller machine, so you have to assume that part of the buffer pool is going to get evicted. What we try to do is optimize for loading up the parts of it that are the most used, but that is kind of a harder problem to do, of course, as you can imagine.
Okay, thank you.
Yeah, you're welcome. Yes, I'll take one from over here.
What version of Postgres is supported in the serverless platform?
I'll need to check on that to confirm, but I believe that it is 10.3.
Okay, great, thanks.
You're welcome. Question from here.
Yeah, two questions. One's a quick one. The whole thing where it scales off 70% CPU or 90% of max connections, is that configurable or is that a hard set thing that it does?
Today, we don't make it configurable, but we've been hearing the requests a lot where customers want to configure it themselves. So that's something we're taking a very hard look at. It's not a difficult thing to do to make it configurable, so you can expect us to be working on that real soon.
And then one more question for Joshua, right?
Yes.
Yes.
So when you said that when you have a query that takes 10 minutes to run on the 2 CPU unit one, I know you can increase the timeout or set a timeout to prevent issues, but what do you do about actually making that query run in a good amount of time? You don't want to have your instance at 8 ACUs all the time, but if you set it to 2 ACU, it goes to 10 minutes. So how did you end up fixing that?
Well, so in our case, we're just allowing the auto scaling to happen. There's enough traffic happening against it that pushes it over that 70%. We do have some edge cases there that we haven't solved yet, which is if that query happens, I don't know, once or twice a day, it may not ever force that scaling event. And so we're looking at that we may need to do some application-specific logging to detect those cases and know to use the API to force the scale. But in all of the cases we've run into so far, there's been enough. It pushes up the CPU load enough to force that scale.
All right, thank you.
Thank you. Yes, sir.
Like I have used Dynamo and they have also this auto scaling feature.
Correct.
But one of the big issue I have seen with that is it will throw provision throughput exception for a couple of minutes and all the request of the client fails and later it will scale it and then it will work fine, which is unacceptable like for my case.
Mm-hmm.
So do you have some similar issues with serverless Aurora that, okay, if suppose my request is very less now and then suddenly there's a big spike within
Yeah.
a second.
Sure. So it can be challenging to handle that very sudden burst, especially if there's a lot of long-running transactions because we're not able to find a safe scaling point. But what you are able to do today with Aurora Serverless is you can always go and explicitly set your capacity to say, hey, I want to set it at 8 or 32 or 64 right now, if you know that that large burst is coming, especially if you're going to be running any sort of heavy workload against your application and you know it ahead of time.
No, my case is okay. Take time, latency means instead of 1 second, I'm ready to wait for 1 minute. But
Okay.
I don't want the request to fail. That is the only criteria I have.
Right.
So whether like it will be able to handle it or it will fail.
Well, we won't typically fail the request. We'll go ahead and do our best to service every transaction that comes our way. We want to make it look as much as possible as though you're talking to a traditional relational database engine. So that's why we look for a safe scale point. If we're not able to find one, then we won't scale up, but we won't just outright reject the transaction.
Okay, thank you.
You're welcome. Question from over here, yes.
Have you noticed any difference in IOPS between Rds MySQL and Aurora MySQL? So for a similar workload in between Rts Postgres and Aurora Postgres, we did notice increased IOPS in Aurora. Because we are charged per IOPS in Aurora, I wanted to understand the story with MySQL.
Right, so there is a pretty significant difference in terms of how storage volumes work with Aurora, which kind of goes to what I spoke about earlier. For some specific workloads, we can see higher IOPS on the volume layer. What you can often get away with doing is running on a smaller server because Aurora at the database server level does have much higher performance to offset that cost difference. But it's a very workload specific question, so I'm not really able to answer it in general terms other than saying you can for certain workloads see higher volume IOPS than you do otherwise.
And for auto scaling, in terms of downsizing, can we configure? Like, can I say if the CPU utilization is 30% or something?
Right.
Will I be able to downsize?
Yeah, so the question really is more generally, can you configure your auto-scaling policies, which is not a capability we give you today with Aurora Serverless, but it's something we're taking a very hard look at. It's an obvious feature that we get a lot of customers ask us about. We did make the service generally available just 3 months ago. We've announced a whole lot of new things, so we're working pretty hard at doing everything our customers ask to do. But you can expect that to be coming.
Cool, thanks.
You're welcome. Yes, question over here.
If using the SDK from a Lambda function to call serverless,
Yeah.
are you still required to have the Lambda function within a VPC, or is that limit?
You are not required to have the Lambda function in a VPC. It can be running from anywhere. So what the Data API gives you is a publicly accessible endpoint. You could call it from your desktop. You could call it from absolutely anywhere. You do not have to be running Lambda in a VPC anymore.
Cool. And it also uses like IAM roles for the access as well then?
Uses what, sorry?
The IAM roles?
Yes, it does use IAM roles to authenticate. We also use the AWS Secret Store Manager to provide your database credentials. Sorry, was there a follow-up question? It doesn't natively support IAM roles the way Aurora MySQL does today, in that you can't use that to solely authenticate, but that's something that we're going to be looking at. Yeah.
Cool. Thank you.
You're welcome. Question over here.
Hi. When do you expect the Aurora Serverless Postgres SQL to be generally available?
Unfortunately, that's not a date I could share with you right now. I wish I could. We've only just opened up the preview today. We're going to be taking a lot of feedback and building our engineering roadmap based on the feedback that we get. If I could give you a date, I would, but I'm afraid I can't.
And how about having this available across regions?
So you want to do cross-region replication between Aurora Serverless clusters?
Yes, yes.
So that's also something we've heard requests for. Today, unfortunately, it's not supported, but it is an obvious feature gap that you can imagine we're going to take a hard look at supporting.
Okay, thank you.
You're welcome. Yes, question?
My understanding is that the query performs based on the history and statistics. When we do the auto scaling, does it also takes care of the statistics, capture the history and cache and all those things?
I'm sorry, does it capture which?
Capture statistics of what are the queries happening, how does the response, on way to look at it. I think I'm going internals of the database.
Yes.
So yeah, does it take the statistics to the new?
Well, everything that's in the buffer pool does get carried across.
Okay.
Yeah.
Okay.
Yes, question?
Yes, you said there was a 40-second start. Is that, and you said also that there was, approaching unacceptable. That's, from my experience, definitely unacceptable. And you said, but what workload in a production environment are you using that has a 40-second startup time that's acceptable?
Right, so in this case, the vast majority of the traffic would be served from the caching layer. So you're looking at that slow start would be from an admin logging in. And then that's the only case where they see it.
I see. So more of a, behind the scenes or a dev environment would be something like that. Production, you're saying some WordPress admin logging in to modify their site.
That's right. And so if you were, regularly needing to talk to the database, it wouldn't ever be pausing, so you wouldn't see it.
And that's my next question. If without the pause, is bringing it down far enough reasonable to assume a cost, to make this cost effective?
Well, I mean, it's all relative. So, the lowest cost runs around, before your IOPS in the $40 a month range. So for some use cases, yes. For others, no. If this is a low volume site where you're trying to have hundreds of them and make it work, then it might not be the answer. But, it really is relative. We are also looking at other options there, like where instead of an instance per site, it would be per customer, and then it would really never be pausing, but you would be sharing the load. There's multiple ways to address the price problem, but there are going to be some cases where an RI T-class RDS will be cheaper. You just have to find the right model for your use case.
Thank you.
Question over here.
Yeah. how good is CloudWatch support for Aurora Serverless? Will it be able to monitor these spikes? I mean,
Yes.
after scaling activities using CloudWatch metric alarms?
Yes, you will. You can get all of the same CloudWatch metrics with Aurora Serverless as you can with provisioned Aurora. So you get the same visibility as you would whether or not you're using Serverless through CloudWatch.
Okay, but monitoring those spikes would be great to have.
So you can see those spikes. The only caveat there is that CloudWatch will sometimes restrict your granularity to 1 minute for certain metrics. So you can't necessarily see them if you're looking at 1 minute granularity. Most of the metrics that I was showing are taken from the client side where you can set an arbitrary granularity. That's probably the best way to measure throughput and latency in that particular context.
Thank you.
You're welcome. Yes, question?
I have 3 questions about the new instance warming process.
Mm-hmm.
So, as I understand, it is done in parallel, so it doesn't stop the original
Correct.
instance. Yeah. So, does it involve reading data from the storage, or does the data is pushed from one instance to another?
Right. It's actually read directly between database servers. It's done so in an asynchronous way so that it won't slow down the primary workload. And if you think about it, it doesn't really matter whether that warm-up process takes 1 minute or 10 minutes because you're not down during that time. We're just sitting there waiting to find a scale point and warming up the buffer pool. Okay. But it is directly between database servers to answer your question.
Okay. And how long does it take with large instances with hundreds of gigabytes?
Well, it's typically going to take anywhere from no time at all up to maybe 5 to 10 minutes in the worst case for a particularly large database.
Okay.
Yeah.
Thank you.
You're welcome. Yes, question?
So 2 questions. Kind of to expand on that last question, these standby instances, I guess,
mm-hmm.
I mean, are they free? Like, how does that work?
Right. So you don't pay for them. We manage the warm pool on your behalf. We absorb the cost of having that standby while it's warming up. All we charge you for is the amount of capacity that you have provisioned at any moment. So you're not paying extra money for the warm pool or for the hot standby while it's warming up.
Okay, so those machines, you have different instances just prepared and ready to go when the time comes. Okay.
That's right.
And the second question is for the, I guess, the cutover point. If you have stacking slow queries,
mm-hmm.
usually when you have like a undersized server, these slow queries will start to pile up. And so they're, like the scenario that Josh had mentioned was a single slow query. And I can understand that you set the session timeout, bam, no problem, that's your cutover point. But if you have these stacking slow queries, you don't know when that's going to happen to give you that cutover point. So in that scenario, are we out of luck?
Well, if you have a large number of very long-running transactions, in that particular case, what we're going to do is we're probably not going to be able to find a safe scale point, so we're pretty much going to lock you onto the server size that you're currently on. So in terms of being out of luck, I mean, that might be a strong word. We won't be able to scale you up or down, but you know, you have to accept that limitation. We make that compromise because we don't want to start rejecting transactions or disrupt your workload. We kind of put the onus as a shared responsibility to say, okay, you're going to need to, you know, tune your workload so that you don't have a lot of long-running transactions in order to get the most out of Aurora Serverless.
Excellent, thank you.
Yeah, you're welcome. So we only have 5 minutes left in the session. I'm going to answer a couple more questions, and then you're welcome to approach me afterwards, and I'll just answer your question one-on-one. Yes, one over here.
One question about autoscaling in Aurora. Is it a vertical autoscaling, or how is it work?
Yeah, so currently Aurora Serverless only supports vertical autoscaling at this time. However, if you're using Aurora provisioned, what we do offer today is an autoscaling capability to grow or shrink your read replica fleet. So you can get that with Aurora provisioned already.
So if we don't have a read-write separation, I'm lost then.
Correct. If you don't have read-write separation, then it's a good use case. If you specifically want to separate your read traffic, it's probably not the best fit for you right now.
Okay, and you don't plan to have a layer like read-write separation or something?
Well, that's something we've heard a lot of requests for, and we're going to be looking at for our roadmap. Unfortunately, I'm not able to share any specifics around if or when we launch it.
Okay, thanks.
Thank you.
So,
okay, last question, and then I'm going to take everything in person right over here. Yes?
So can we go back to the slide with the preview link like you posted today?
Yeah, let me see if I can find it.
Thank you.
Would you like the source code? Is that?
No, with
the
with
preview
page,
for,
with the pages.
Right. And all of these slides we will be publishing online, so you don't have to, I mean, you're welcome to take pictures of them, of course, but we will be publishing these slides and making them available to all of you. So we only have 3 minutes left in the session. I'm going to get in trouble if I continue. I'm sorry to cut off the questions, but I will be right over here to answer any questions that you have. Thank you very, very much.